Alright, in this video, I want to give you a little brief introduction to scientific notation and metric prefixes. So I'm sure you probably know a bit about this stuff already, but I just want to cover it, make sure we're all on the same page. So first, talking about scientific notation, that's when you have a number and an exponent here. So say 10 to the second power, 10 squared. What that means is just 10 times 10. So that'd be 100. So 10 squared is the exact same thing numerically speaking as 100. It's just a different way of writing it. So let's say now we have 6.5 times 10 to the second. So this is a number in scientific notation. If we're trying to figure out what this number is written fully out, well, you can take 6.5, the number that you see right here, and you can use this to move the decimal from this 6.5. So if you have a positive exponent, what that means is basically you have to move the decimal over 2 spots to the right. Because again, what this is saying is it's basically saying 6.5 times 10 squared, right? 10 squared we just said is 100. So it's another way you can write it is 6.5 times 100. So if we move the decimal 2 spots over to the right because it's a positive exponent, we can now put the new decimal there, and we would fill in any blanks with a 0. So our new number is 650, which 6.5 times 100 is 650. So this 6.5 times 10 squared is, numerically speaking, the exact same thing as 650. It's just a different way of writing it. So let's try it with another one. So let's say we have 7.8 times 10 to the 4th. Alright, so we can write out 7.8. Now, it's a positive exponent again. So a positive exponent, you move the decimal to the right. And this time we're moving it 4 spots. So we've got 1, 2, 3, 4. The decimal now goes there. And again, any blank little bumps, we'd fill in with a 0. So our final answer would be, this number is 78,000. Now let's say we have instead 7.8 times 10 to the negative 4th. If you have a negative exponent, you're basically just going to do the same thing, but instead you have to move the decimal over to the left. So we can start, once again, by writing out 7.8. This time we move the decimal 4 spots to the left because of that negative right there. So 1, 2, 3, 4. Decimal now goes there, and once again, any blank bumps, fill in with a 0. So our new number, so I guess what I should say is, this number is actually the same thing as 0.00078. Now let's say we're trying to go the opposite way. So let's say we have 0.000052. And so, as you can see, you can end up getting some really, really small or really large numbers, and that's what scientific notation is really good for. So it could be used for that, and also for the purpose of sig figs, which I'll talk about in a video coming up. So, if you're trying to convert this to scientific notation, what you always want to do is you want to put the decimal just to the right of the first non-zero digit. So, reading left to right, the first non-zero number we come across is 5. So you want to put the decimal just to the right of it. So we'd have 5.2. So 5.2. And they were saying, if we have 5.2, to get to this actual number that we want, how would we have to move the decimal? Right? So you can think, if the decimal was right here, how would I have to move it to get it to where I actually want it? Well, we have to move it to the left. So right off the bat, moving it to the left, you know it's going to be a negative exponent. Now let's say we have to go 1, 2, 3, 4, 5 spots. So it becomes 5.2 times 10 to the negative 5. So this number, written in scientific notation, is 5.2 times 10 to the negative 5th. Okay, now I want to talk about some common metric prefixes. So I will post on Blackboard. I'll have a sheet of some common equations and conversions, and these will be on here, but these ones that I'm going to give you, it would definitely be a good idea to memorize them, because you'll be using them a lot, and it would definitely save a lot of time and energy if you can just remember what these prefixes are. So I highly recommend it. So let's start with, I guess, kilo. And kilo is 10 to the third. Now what does that mean? So when we're dealing with units, so let's say we're talking about meters right now. So if we have 1 meter. So again, these are metric prefixes. So this kilo can be a prefix for the word meter. So what is a kilometer? Well, a kilometer is 10 to the third meters. Right? So it basically means that's its relationship to the version without any prefix. And 10 to the third, what is that? Well, remember that's 10 times 10 times 10, which equals 1,000. So that means that there are 1,000 meters in 1 kilometer. Right? Let's go above that is mega, and that's 10 to the 6th. 10 to the 6th is a million. So there are 1,000,000 meters in 1 megameter. Now let's go the opposite way. Deci is 10 to the negative first. So what does that mean? Well, just like 10 to the third means that there's 1,000 meters in 1 kilometer, there are 10 to the negative first meters in 1 decimeter, which means that there are 0.1 meters in 1 decimeter. Which, mathematically speaking, means that there are 10 decimeters in 1 meter. So now all of these, with negative exponents, that means that they are smaller units of measurement than the version without any prefix. Going below that, we have centi, which is 10 to the negative second. Now you probably know that there's 100 centimeters in 1 meter, and that's actually what we see right here. This 10 to the negative second means that there's 0.01 meters in 1 centimeter, which mathematically is the same thing as saying there's 100 centimeters in 1 meter. If we keep going below that, milli is another very common one you'll see, 10 to the negative third. We have micro, 10 to the negative 6. Nano, 10 to the negative 9th. And I'll go one more, pico, 10 to the negative 12th. And so not only can you relate these to the version without a prefix, meters in this case, but, and don't get me wrong, it doesn't have to be meters, it could be grams, liters, whatever unit we're talking about. But you can relate them to each other too. So for instance, if there's 1,000 millimeters in 1 meter. You know that because 10 to the negative third, right? So there's 1,000 millimeters in 1 meter. And I said that there were 1,000 meters in 1 kilometer. So how many millimeters are in 1 kilometer? Well, it would be a jump of 1,000 to get to meters, and then another jump of 1,000 to get to kilometers. So it's 1,000 times 1,000, which is 1,000,000. That's 10 to the 6. Now you could have known that if you just basically count the difference in their exponents. So if you're just counting from negative 3 to 3, you have to go negative 2, negative 1, 0, 1, 2, 3. So you have to count up 6. So there's a difference of 6 between their exponents. 10 to the 6 is the difference between them, which is 1,000,000. So you can also relate between these values as well. Right? So for instance, there's a difference of 1 between decimeter and centimeter. So that's 1 factor of 10. Is what that difference of exponents means. So there's 10 centimeters in 1 decimeter. And then just lastly, real quick, I want to talk about some SI base units. So SI base units is it's an international system of measurement. There's actually 7 of them, but only 5 of them that are, I believe, going to come up in this semester. So I'm only going to talk about 5 of them. So if you ever asked about an SI to use something in an SI base unit, this is what they refer to. So the base unit for length is meter. Now the base unit for mass, this is the only one that actually in its base unit has a prefix, and it's kilogram. Now don't get it mistaken. When you're using these prefixes, gram is the portion that you use. You wouldn't say kilogram. You would just say kilogram, right? So this kilogram is actually already 10 to the third grams. The only reason that the version with a prefix is used for mass is just because a gram is actually a really small unit of measurement. So kilogram is more practical in daily use. The base unit for time is seconds. For temperature is something called Kelvin. Now you may not have heard of Kelvin yet, but you will get very used to it as the semester grows. It's used in science a lot, and we'll be using a lot this semester. And actually, for this last one, is another thing you might not know of now, but you'll become very, very intimately familiar with throughout the semester. And so for the number of a substance, which basically just means, like, if you're counting how much of something exists, we use something called moles. And again, that might not make a whole lot of sense now, but the mole is arguably the most important concept that you'll learn about this entire semester. So you will most definitely be much more familiar with it before too long.